The planet has now entered what is called by scientists and others the rim of fire. The rim of fire can be located as starting in the South Island of New Zealand, going up through Indonesia, through Japan, to Alaska, coming down to California, and going down to Chile. And it touches a few other areas, but this is it. It's primarily the Pacific Basin, which is a rim of fire. And no nuclear explosion organized by man could ever even approximate the power of this rim of fire. The sun has recently gone into a new phase, a kind of phase it's gone into repeatedly in times past, a period of extreme violence, which used to come with an 11-year cycle, is now apparently coming with a 13-year cycle. What happened in Japan is simply a part of an ongoing process which is generated by nothing but the sun itself, the effect of the sun. Now, in order to deal with this crisis, which having hit the South Island of New Zealand, coming to Japan, headed in the direction of Alaska, headed in the direction of California, and down again toward Chile. This thing is something we're going to have to learn how to deal with. It's not a nuclear explosion. Nuclear explosions have nothing to do with this. It's a rim of fire, well known to all specialists in this area, on this subject. Now, what we can do about this will be presented to you in some detail in the following part of this report, which indicates to you what some of the problems are that we have to understand. Problems about what does the sun have to do with this? How do we know this? What do we know about it? What don't we know about it? What are we going to do about it? This indicates that we're going through a period, probably through this year into the year 2013, which will probably be a period of greatest risk for various parts, especially parts of the rim of the Pacific, the rim of fire. And so the report that's about to be given to you now, following my remarks here, will make the matter clear to you.
On the same day of the earthquake, there were auroras, the northern lights. People reported from Canada down as far south as Madison, Wisconsin, reported seeing these brilliant light shows in the nighttime skies. Now, was this just a coincidence that this occurred on the same day as the earthquake, or is there some type of correlation scientifically?
Well, it's very interesting. It was a phenomenal display of the aurora borealis. But to say that the earthquake caused the aurora, or that the aurora caused the earthquake, would be a mischaracterization. The aurora itself was apparently generated by what's called a coronal mass ejection from the sun, which impacted the Earth's magnetic field on Thursday afternoon. The coronal mass ejection was generated by a series of solar flares that occurred earlier in the week, Monday through Wednesday, which occurred in the context of the sun increasing in its solar activity after a several-year hiatus period. Now, the issue is that, yeah, the auroras were generated by the radiation from the sun. But if we look back at the past several earthquakes, you do see a correlation between solar activity and tectonic activity. For example, the recent earthquake that happened in New Zealand on February 22nd happened a little over a week after this whopper of a solar flare, which was the largest solar flare in 4 years. The Haiti earthquake, which happened last January 2010, occurred 2 or 3 days before a series of very powerful solar flares. So it's interesting that the coincidence in timing of the solar activity is so close in time with the tectonic activity, but you can't say that there's a causal relationship between them. So the question is, what is the relationship?
Just to clarify, has there been a change recently in these types of activities of the sun? I mean, you're saying that the aurora indicates some type of heightened activity on the sun. How frequent of an occurrence is this? Is this something that happens all the time, or has there been an increase?
Yeah, we're coming right out of the solar minimum, which is typically an 11-year cycle. That every 11 years it goes through a minimum and then a maximum. This particular cycle has been about 13 years, which has some interesting implications in terms of global climate. But usually it's an 11-year cycle. So you could look back and say, well, is there a correlation between increases of solar activity and increases of tectonic activity, such as the earthquakes, but also volcanism?
What is that cycle actually? What do you mean by the solar cycle itself?
Within the 11-year cycle, you see a decrease in the number of sunspots on the surface of the sun. And Herschel, back in the 1800s, recognized this, that the sunspots become more and more dense and then dwindle to nothing, and then get more and more dense and dwindle to nothing on a cycle of 11 years. It's actually a 22-year long cycle, but it appears as an 11-year cycle because it goes from one pole to the other. But this is, when you have more sunspots, this represents the fact that the magnetic field of the sun, which is also known as the interplanetary magnetic field, because this thing goes all the way out past Jupiter and Saturn. These are periods that the magnetic field of the sun gets much more intense and much more active, which is what's represented by these by the sunspots. And the solar flares actually follow the path of the magnetic field off the sun. So these are periods of heightened magnetic phenomena on the sun.
Could you say something about the relationship between the sun and the earth? What is actually going on in that space? Because I think most people just have the concept of the sun providing warmth, providing light to the earth, but don't have much of an idea of what is that space between the earth and the sun.
Yeah, the big problem is that people consider that the solar system as a whole is really just, 9 objects floating around in empty space plus this big sun, and we're kind of defending ourselves in this little corner of the solar system all by our lonesome. When in fact, if you go back to the works of Kepler, even he recognized this, that we're dealing with a unified whole system, that there are not individual separate objects in the solar system, but that there's a solar system, and the activity of that system is as a whole system. So in that sense, you have to be interested and intrigued by the correlation between the increased solar activity and then the increased geophysical activity. Because if you look right now, you had the earthquakes in the past 2 years, which are some giant earthquakes and had various effects. At the same time, just recently, within the past week, we've had explosions of many of the volcanoes around the so-called Ring of Fire, the Pacific Ocean rim. So you have an increase in geophysical activity at the same time that you have an increase of solar activity. It'd be a fallacy to say that the sun, that these solar flares are like shooting at the Earth and creating these explosions on the Earth. It would be more accurate to say, and this is something that we have to follow up on in terms of actual experiments and investigation, it becomes more clear that the solar system as a whole is right now going into a more active period, which is represented by these outbursts from at least 2 known bodies in the solar system. And I would say that we should look for more outbursts like this.
Yeah, I think that the tendency would be to say, well, are the flares causing the earthquakes, or are the earthquakes causing the flares, when that's really not the right question, because you're looking at a highly dynamic system from what you're describing. Mm-hmm. And there's potentially a higher cause, but it seems like we're seeing some type of correlation between the two. So then how how do we approach figuring out what is that higher cause?
Well, the first thing is to look at what happens on the Earth. You have to be a little bit more broad than looking at earthquakes and volcanoes as just pieces of rock moving around on the Earth. That is just static things that are, periodically shifting and moving. You have to look at in the domain of what we call cosmic radiation. So, for example, around earthquakes, there's a phenomenon of eyewitness accounts of various kinds of strange lights that happen around the epicenters of earthquakes. Many people have described seeing strange lights. For example, in the Chilean earthquake back in 2008, there was a show of lights around the area in Chile where you had the earthquake, and some people claim to have actually filmed it.
You're saying they see lights during the earthquake? Or?
Almost like there's lightning or something like that in the distance. And some investigators have actually surveyed people around the world who have been near earthquakes to make clear that these people aren't just seeing things, but this is a widespread phenomenon. Earthquake lights. Something that's also reported very often are strange, erratic behavior of animals, like dogs and cats, for example, they have a legendary ability to forecast an earthquake before it happens. Snakes will take off from the area. Rats will flee an area. Other phenomena like strange weather patterns right before an earthquake. These are all eyewitness accounts, and we've been having these eyewitness accounts going back for hundreds of years. Now, there have been attempts to explain this stuff. The usual attempt is that people are just crazy, which is not true. But other attempts have been to say, well, maybe there is some kind of electromagnetic phenomena happening that the animals can sense and that people can see sometimes.
It's not just a mass hallucination in different parts of the planet at different times.
Right, like right now there's a mass hallucination that there's no such thing as a British Empire, right? But no, it's not a mass hallucination. There is some kind of a real effect going on. So the question is it an electromagnetic effect? Because then you would have a connection between the sun and the earth through the fact that we are living in a cosmic radiative environment. So some of the other effects that have been recognized is, for example, there are magnetometers near the time of an earthquake, before the earthquake, can register long-wave, strong changes in the geomagnetic field. These are called very long frequency or ultra-long frequency oscillations, which are very high amplitude. They're very strong oscillations, but it's about 5 to 10 cycles per second changes in the geomagnetic field. And for example, the whopper that hit Alaska in 1964, which was magnitude 9.2.
Are you talking about a cycle of a change in the magnetic field, or anomalies and irregularities from what is known as the regular shape of the magnetic field? Well,
the geomagnetic field already has secular variations, which are determined by some phenomena inside the Earth, but also determined by activity of the sun, for example. Our magnetic field is very closely connected with the interplanetary magnetic field. But what these guys are measuring, for example, this 1964 Alaska earthquake, there was a magnetometer which happened to be very nearby and also at a high level so that it wasn't damaged in the earthquake, measured, it was between 5 and 10 hertz cycle of change of intensity and direction of the earthquake, or of the geomagnetic field, about 2 hours before the earthquake actually hit.
So an actual change in the Earth's magnetic field preceded the earthquake?
The magnetic field of the Earth, the local magnetic field of the Earth, changes in response to an earthquake before the earthquake actually happened. The idea that a magnetic field is going to shift the rocks on the Earth is kind of a strange idea, but the fact is that the rocks do shift coincident with some kind of a discharge of electromagnetic radiation, which changes the magnetic field. It can be picked up by weather satellites as increased infrared radiation before and after the earthquake. It can also be picked up by some of these global positioning satellites, which have to essentially shoot signals back and forth through the ionosphere, which is a charged layer of the atmosphere. And they pick up that days before, up to 6 days before an earthquake, you have a change in the ionosphere above the area that the earthquake is going to hit. And then that change diminishes after the earthquake over a period of several days. So you do have a coincidence of electromagnetic phenomena and tectonic phenomena. So the cause is not clear yet. That's one of the questions that we need to look towards answering. But the relationship is definitely there.
Now, in recent videos, some members of the basement team have been discussing the 62 million year cycle of the solar system through the galaxy.
Mm-hmm.
And the different effects that this has for us on Earth, changes in influx of cosmic radiation, in biodiversity, etc. Does this come into our equation here?
We're going to be releasing some more material on this over the coming days as we investigate it. But yes, there is some clear relationship. You have the 60 to 62 million year cycle of biodiversity, which you mentioned. Some of the researchers who identified the 62 million year cycle threw open a net to say, okay, what other cycles on the Earth do we know of that follow a roughly 60 to 62 million year cycle? One of them was the tectonic changes on the Earth. And we've seen that in the great so-called mass extinctions, like the extinction of the dinosaurs or the Permian-Triassic extinction, that those extinctions are associated with increased volcanism and other increased tectonic activity. In fact, the Permian-Triassic extinction is actually, which was like the big mother of all extinctions, like 98% of the species went extinct, is today blamed predominantly on an explosion of volcanism on the surface of the Earth. So there is a 62 million year cycle of this tectonic activity. Now, what we're interested in is the fact that the anti-entropic development of life on the Earth, which goes through these so-called mass extinctions in the form of transformation of the organisms into higher and higher types of organisms, and a transformation of the whole biosphere in these shifts, that must be due to a change in the cosmic radiation environment of the whole solar system. So therefore, a current link that, were we to be able to find a link between increased cosmic radiation in the form of the sun's activity and increase in tectonic activity on the Earth, then we have an experimental domain to work with, while observing the fact that you have increase of tectonic activity and rapid transformations of organisms, periods of transformation of organisms on the Earth, which is periodic. And the other interesting thing is that the 62 million year cycle is not a solar system cycle, but it's actually a cycle of our travel through the galaxy. So this is a galactic transformation period.
Well, it really seems like, well, there's a lot of implications for what you've just gone through. A lot of what we witness on Earth every day is the result of a higher process, but then also it seems that there's a real coherence between these developmental processes, the development of organisms, and in these tectonic shifts that are an effect of a higher process. I'd like to ask you what we should do with this. I mean, where do we go from here? What do we need, given the current economic and political situation that we're in? Where do we go with this?
Well, over the next couple of days, we're going to be pulling together a more detailed picture of the implications. But for now, it's pretty clear that step one, besides dealing with the immediate damage of in Japan and the surrounding areas due to the earthquake and then the gigantic tsunami, we need to get rid of President Obama. That would be the best first step. and then we could put through the Glass-Steagall and the other types of economic changes, so that we can start putting back together our human spaceflight program. We need to do things like NWAPA and rebuild the system of human control over the biosphere. But along with that, we need to, again, rev up our acceleration of human beings into space. Because, for example, we need to see what types of seismic activity happens on the moon. We need to see what kinds of seismic activity happens on Mars. We don't know. Perhaps Mars is having earthquakes right now, too, that are huge, that we can't measure.
Do we measure seismic activity on any other body besides the Earth?
Well, the Apollo astronauts put seismographs down onto the surface of the moon, but those were shut off pretty soon after the Apollo program was ended. So we used to, but now we're confined to the surface of the Earth. What we need to see, is this a solar system-wide phenomena? And the only way we're going to do that is by getting out into space with people who can do the exploration and put the types of devices out there that we need.
Right, because if we're not measuring the possibility that this could be an effect on the level of the solar system, then it's going to be very difficult to determine that higher cause.
Exactly. If we stay on Earth, we're pretty much screwed. We got to bring people and cats and dogs to the moon and to Mars to see if they respond at the same time to heightened solar activity the way they do on the Earth.
We've come to a time that science must advance itself to the point that we understand better how to deal with some of the peculiarities of our galaxy. Because our solar system, of which the sun is the center, is merely a part of our galaxy, an integral part. The galaxy is not something distant from us. We are in the galaxy. We're on the rim of the galaxy. That's where the solar system is. And often in the past, like the extinction of whole species some time ago, entire species were wiped out and new species emerged of living species on this planet. It was caused by a temper tantrum of sorts, you might call it, by the galaxy. And these are the kinds of things we have to finally come to understand. How does our galaxy work? How does our solar system work? And what are we going to do about getting out there with space exploration by man to find out what really goes on the moon, to find out some of the other things that determine what is going to happen to us on Earth? We have to get out there and find out what it is. And exploring the solar system is one step, but understanding the galaxy is absolutely indispensable.